Okay, everybody, we're live again.
Hey, we're back.
There's nobody. There's no one watching.
We're on a new live thing. We lost the connection here at the Wi-Fi in the factory here. Something must have happened, and so we're back here. Hopefully, you guys have reconnected. You can always scrub backwards, even on the live feed here, and see what's happening. What we were talking about a minute ago was kind of the polar coordinate rotation stuff on live tool lathes, and we're going to do a video on that soon. And what we were talking about is that we've got a lathe certification program coming out, and so the lathe's been tied up making those videos, and that thing is about ready to go live sometime in the next few weeks or month, and so be keeping an eye open for that. But in generally what they were asking about was, how do I take an XY program and convert it over to run in C-axis rotation and X move? And it's really easy with the Haas control using a G112. It's that G112 command. And all the nuts and bolts of how to make that work are worth mentioning, but they're so good. We're gonna put that into a full-length tip of the day video and give you some good examples. If you need something right now, if you're stuck and you wanna do that, email us at tod@haascnc.com, and I'll send you some program examples. Look up G112 in the Haas lathe manual, and they've got some examples in there, but I've got plenty more on that particular code, and we'll make a video on it as well.
Sounds good. Okay, so we just a couple days ago released their inch versus metric question of the day, and of course that got a flood of responses, people on the inch and the metric side, as we figured it would. I just wanted to read a couple of these comments and then let you pontificate about it a little bit. Dr. Johnson says, the only time I use inches is when I'm measuring TVs or speakers. Alex Mays says, shout out to USA, Myanmar, and Liberia for keeping this ancient system alive. Special mention to the UK for trying to use both at the same time. And then Bill Strahan, he jokes for a little bit, and then he says, based here in the USA, and it's metric for everything. The last thing to shift as far as inches was MMR, or material removal rate. Once I just figured that 1 cubic inch MRR is about the same as 16 cubic centimeters, I finally shifted to thinking in metric terms for measuring MMR as well. So to me, that kind of seems like the thing is having that feel. If you're in inch, getting the feel for what metric means in terms of feed rates and stuff like that. Is that maybe your take on it, or?
Oh, for sure. Yeah. It's I can't think of this topic anymore without thinking of every single meme I have seen in the last year on metric versus inch. There's some great ones, right? They have all the coronavirus memes out right now where they're saying stay at least this far from somebody else, right? That 6 foot rule, but the pictures will show an alligator. Right? So in Australia, they might say stay at least 1 crocodile away from another person, and all the hashtags, right? They're all saying anything but metric system. And so we'll say stay this many red plastic cups away from this person, or this many crocodiles away from somebody, anything but calling it 2 meters. And so it's a funny thing. But switching back and forth between inch and metric is kind of like learning a different language. First, you start thinking, okay, cat, okay, el gato, and you're converting it in your head. And eventually, you start thinking in that other language. So I worked at a job shop and converted prints from metric to inch for years and years. And I always converted things in my head. And eventually, I went to an all-metric shop, and you start actually thinking in metric, where you look at that and you don't think, okay, that's a half an inch. You think, oh, that's 12 or 13 millimeters. You think in metric. And so eventually we'll all get there. But the straw poll that was connected to that last video, and if you're in North America, not North America, the United States, go on, watch that most recent Haas tip of the day video, click on the link in the description for the straw poll. And this is where we're at right now. I don't know if you can see this, but this is totally unscientific, but it's supposed to be for the red is metric and the green is inch, and they're saying how many of us here in the United States are actually running machines in metric mode as opposed to inch mode. And according to this unscientific straw poll, about a third of us, or at least a quarter, are running our machines in metric. So if you'd asked the same question 10 years ago, I'm sure it would have been half that number. So slowly but surely, we are adding more kind of international standard to our repertoire. But it's a great question.
Yeah, one of the other comments that repeats over and over again is the question of, is there some actual improvement in accuracy between going from inch to metric? And you went down that rabbit hole with one of our software engineers. And
so the biggest difference between inch and metric, right? If you're running your machine in metric mode, you'll realize that it's got 4 buttons here, and so if you were to use the smallest button, the increment's smaller on the machine, and so you might jog at a different rate, slower in metric than in inch. But is the machine actually more accurate in metric mode? That was a question that was asked me a month ago by a Haas user, and the simple answer I would give is no. The machine is no more accurate in metric mode than it is in inch mode. The real technical answer is maybe. So if we're talking actual encoder counts per micron, per 0.001 millimeters, or encoder counts per thousandths of an inch, then we actually do have more encoder counts per micron than we do encoder counts per tenth of a thou. And so in theory, not practice, but in theory, yeah, the machine might hold whatever, some millionth of an inch positional tolerance better. In practice, I just don't see it. I don't see it any difference on my ball bars. I don't see any difference on my parts switching back and forth. But at least in theory, yeah, you get a little tiny something.
let's go to an email question. This is from Charles Banning. Does G1213 only machine pockets, or can you use it to machine a boss?
So G12 and G13 are actually defined as a circular pocket routine, and the key word there is pocket. G12 and G13 allow you to remove material and rough out the entire thing and finish it on ID pockets. And so G12 and G13 are only good for inside work, not outside work. But if you've got the Haas control, it's got VPS. I haven't done this, but if I come up and over and down to VPS, oh, the first one there, circular contour milling. So this is making a boss. We can do this, but if I ran through this conversational programming on the control, VPS, it would spit out the code to machine this boss, but it's going to spit out the code in G2s and G3s, in right and left-hand arcs. It's not going to use a G12 or G13 code to do it. So if I go to a circular pocket where it's making a hole in the part, in this case, it's going to use a G12 or a G13 for all those roughing cycles. So there might be some way to lie to the code to make it create a boss instead of a pocket, but it's not typical, and it's probably just going to give you some weird results. So yeah, G12, G13 are only good for ID work.
So we've got over 100 folks who
They're back. We appreciate that. Thanks for coming back.
Rejoined us on our new feed. And by the way, if we have any technical issues, of course we'll bring the feed back up, and we'll keep on trucking.
That's right. All right, let's jump over to a question that we got on one of the previous live chat posts. Simon Gache, I guess. Can you please talk about the best high-speed steel on the market currently, and touch also about your recommendation on carbide inserts? There's an open-ended one for you.
The best grade of carbide.
Yeah, I guess the best grade of carbide.
I don't even worry about it anymore. So today, I can't buy bad carbide. I know that it used to be like, oh, you need the right grade of micrograin carbide. And I used to worry about that, what grade of carbide, and I used to worry about what the grind was on my tool shanks, right? You know, your H6, 7, 8, 9, whatever, on the grinds on those tools. And I just don't worry about that anymore, because just about every tool supplier I get tools from has that stuff figured out. Their carbide's all great, their grinds are perfect on their shanks, this type of thing. Normally when we're talking about grades today, if you look up a Sandvik insert compared to a Kennametal insert, you'll see a different grade on them, but that grade doesn't just correspond to the type of carbide that they're using. They're talking about coatings. So if you have a GC 220 or whatever the number is, that's going to be maybe a TICN coating, and Kennametal might have a KC 4335 or whatever the number is, and that's going to refer to the coatings, and that is still really important, but it varies by manufacturer. So today, I would say that the biggest impact on your cutter life is just the design. Are you getting the right tool for the job? And beyond that, it's the tool coatings. So those grades that you're running make a difference if you're running on titanium versus mild steel versus aluminum. And so you have to just check with the manuals on that. But generally speaking, as far as the actual carbide micrograin, I haven't worried about that in a lot of years.
And maybe I would suppose that high-speed steel tools are probably fall in the same kind of category. If you buy a reasonably, at least a mid-level, especially a cobalt tool these days, you're gonna get a good performing tool.
Now it makes a difference. So and the grade of carbide does matter. If I've got an insert that's running in I'm coming into this cut, this edge of my table is my cut, and if I'm smacking the tool, where the tip of it is hitting first, it's hard to explain. If I'm at a negative rake angle when the material hits the material, it's not going to be touching the tip first. It's going to be cutting on the side of the material, and that's the way you want to do. You want your tool to cut into the material where the side of the insert touches, not the tip first. It's hard to explain. Negative rake angle there. If the first thing that cuts into the material is the tip of the tool on the material, the problem with that, if it cuts in like this, if the first thing to touch the material is a tip, well, then you're going to really damage the tip of the tool. And if it's hard material, you're going to wear out that tip quicker. So the grade of the carbide, I'm kind of backtracking a little bit, it does matter because you really need a shock resistant insert, something that can handle this type of impact. But if you've got a lower negative rake, then the first thing to hit the insert is not the tip, then we can use a more standard carbide, and it's going to bump up your tool life quite a bit. So there's different ways you can actually create your tool paths to make your tools last longer. And if you're running on tough material or your lead in, lead out are at a funny spot, you might need a different grade of carbide that's more shock resistant. So, but that's all wrapped up into the grade, the quality of the carbide, whether it's shock resistant or not. And you've also got the coatings. And so that's all wrapped up into the grade. So it's really on a case-by-case basis what you're cutting.
I got to call an audible here. John Demmer just threw out a great comment. He's saying, thank you for all the tip of the day videos, and lots of them apply to his CNC knee mill, which is super cool.
It's funny. So much of this stuff just transfers over. And we talk about even manual machinists and how that's a different world. So much of it's the same, right? If you know how the cutter reacts, if you know how the metal moves, so much of this stuff translates from one machine to the next, and it's all useful information.
All right, another one from the feed here. JC asks, programs from the MGC control, are they able to run on the legacy control?
Yes. So it's almost 100% compatibility. Now, with every year that passes, we at Haas add more G codes. We add extra control to everything. So we're always adding new cycles. So if you run a 1998 machine, that program, that code will load right up into this newer machine and run just fine, absolutely just fine. If you take the code from here and you put it back into a 1998 machine, that same code's going to run unless it's a brand new G code. If it's running in some new style, whatever, like some of our CAN cycles might have an E value on it to get rid of the chips. Well, that cycle didn't exist in 1998, so that code is going to alarm out on an older machine. But all the basic codes are all the same. But just like anything, every time we add a new G code, it only works on the machine that has that software available.
Yeah, makes sense. Okay, so this is actually a couple of comments that we got in the last week or so. Let me find it here. Okay, Florian Bleiler asks, can you explain the G10 code, please? And then we were talking about that for a minute, and then we wanted to bring up this other comment that was from one of the 4 tips in one day, tip of the day. And Chevy G Body 1987 said, need that red die come daily. I don't scrap parts, I make setup pieces.
Oh, okay.
So you were going to talk about, the
good parts, bad parts.
things you need to consider when you're going to run G10.
So G10 is awesome. It's terrific. Great code. Comes after G9, before G11. That's about it. G10 is for writing to tool and work offsets, typically. So you might use a G10 L2 P1 to write to your G54 work offset. Now, why would you want to do that? If you're running a horizontal machine, you know exactly why. Because the program exists in the control at all times. The parts are already set up on a pallet in the pallet pool, and every time that pallet comes into the machine, then you're going to reuse G54. So the G54 part on one pallet is different than the G54 part on another pallet, and so you need to be able to rewrite to the G54 work offset for one pallet versus another. And today, with all the modular fixturing that you see on machines, even small vertical machines, you're seeing a lot more of that as well, because my fixture might be different from one pallet to the next, the position of my G54 part. And so when I put in this part and I run this particular program, I actually rewrite to my G54 work offset with a G10 code. And so I'll G10, L2, P1 for whatever it is. We can look that up. Look up G10 in your Haas manual, and you can learn how to do that. Also, sometimes if you're running a job that you've run before, you might want to write to a tool offset. And so you can run a G10, L10, or whatever the code is, and write to your tool offset as well. A G10, L10, P5 might write to tool offset 5. I tend to not use G10 to write to my tool and work offsets as much as I use my macro variables. So if I'm writing to my G54 work offset, my XYZ value, I might use, I'm forgetting the numbers, but they're going to be a pound 5221 or something like that, 5221, 5222, and so on, or something really close to that. And so I'll use the macro variables because a lot of times I'm doing math with my work offset. I'm saying that work offset G55 is 1 inch to the right of my G54 work offset. So I'll, pound 52 or 5241 equals 5221 plus 1 inch. There's math involved. So I'll use the macro variables when I'm doing some type of calculation with my work offsets, and then I'll use G10 when I'm not. When I'm just putting out a number, I just want to quickly write to my tool or work offsets. And so they're amazing. And if you haven't used a G10, you're going to soon in your career. As everyone starts moving towards modular fixtures that move around, you're going to find out that it's just much easier. Instead of picking up beep, 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 even if you have a probe, it's faster to just put the program in there, press go, and it'll write to that work offset because it already knows where it is. With a G10, you're going to be doing that instead of reprobing that first part when you change that pallet every time you change the fixture. There's no need to reprobe because your subplate has the dowel pins and that hasn't moved. So when you put on your top plate or your fixture or your pallet, all you got to do is write to that G54 work offset or that tool 1 tool offset. Fantastic code. We should make an entire video on that. I want a horizontal. We have a hard time with horizontal machines here because they come in and they go out. We sell them too fast. They're pricier machines. We don't have one here in the photo area, and so an EC400 would be a great machine to show off that topic with. But we'll just do it again. We'll do that topic anyhow with just a regular vertical. It's the same code.
Somebody was mentioning the green light blinking, and they were asking if you could shut it off.
If we could shut off my green light, that'd be perfect. It was just saying that the green light, if you're an operator, you know what that means, right? The flashing, it means get over here and change the part. My program is finished, and I'm done. It's waiting for you to change the part. That's like a stressful light for Haas operators. If you look across your shop and you see nothing but flashing green lights, you're like, oh, I gotta go change the parts. What's worse is like, the flashing red light, and we won't talk about that.
So I just want to say thanks again, everyone, for finding our second stream here after the first one went down. We're up to almost 170 people in the chat from, again, all over the world, which is really great to see. Loki97 asks, in your country, Corona is there or not? And yes, it is here. I just don't have this on right now, but this is what we're all wearing at the factory. Frank's got one on right now. Yep. We're hopefully far enough apart that this isn't a problem, but this is what we're doing. Everyone in the factory wears these. Just another way we're trying to protect everyone from everyone else. Make sure that no one gets it. We're pretty lucky in this county, in Ventura County, that the rates of infection are very low. So anyhow, you take that off. Next up, let's go to Smooth Monty asks, hey Haas TOD crew, how would you set 0 on a slitting saw on a right angle head?
That's getting complicated.
Wow.
A slitting saw on a right angle head, that's getting deep. So we made a video all about setting up right angled heads. If you go to Haas, you don't have to look at the camera here, but I'm gonna do it. I'm gonna go to Haas Automation, YouTube, and with that up, I'm gonna go Haas, I'm going to YouTube, Haas right angled head, enter, and sure enough, there's a video there on setting up a right angled head on a Haas vertical machine. Goes all into that, and we show you how to touch off typical tools like a drill. The easiest way to program that, a slitting saw with a right angled head, is program the tool off center line. So when you come in with your slitting saw, you simply touch off on the edge of your slitting saw, and then bring the tool down by the radius of the tool, and now your tool is basically touched off on center line. And that's the way you want to program. You'll program that tool off center line, and everything works out. So go to Haas YouTube, Google, Haas right angled head, and watch that video, and you can see how we do it.
Alrighty, another question here in the chat. Kevin Henry asks, were you guys talking about a lathe certification program before the video cut out? And I think we were you were just beginning to mention it. We are extremely close. All the videos have been done. We're just working on wrapping up the behind the scenes stuff, like all the tests, how the actual program that administrates it works. Not how it works, but making sure everything's loaded up and looks correct. We also got another question along the same lines. Mama Andre asks, when do you plan to give access to certification in countries besides the USA? And we've talked about this a little bit. We're presently working on translations, basically done with translations for Spain, Italy, Germany, and France. And those are the first ones we've got going here. Those are very nearly done, ready to be put up on the website. Same thing there. You got to build in, the website so that it can take care of that. After that, we're planning to do more. I don't know. None of us knows yet what that time frame is going to be. But yes, the idea is to get that out to as many countries as we can. And then we will plan on doing the same thing for the lathe certification. I don't know if I should mention, we probably talked about it before, but we are also planning for further programs. We were just beginning to do the development work on the intermediate mill program. So kind of a cool, gives us a chance to kind of get more specific now. Breaking news, yeah. Hopefully I was supposed to say that.
Very cool.
Yeah, so I think that's something to look forward to as well. Anyway, let's move along here. Yeah, go for it.
The certification programs are fantastic. This morning we were talking about something on the control we were looking at, and we're saying, we got to put that in the manual. And we're going back and forth on that. And my comment a few minutes later was, if I get hit by a bus, I've got to write that down for something like this before I forget. And I'll say this, that term, if I get hit by a bus, no one expects to get hit by a bus, and we don't really mean being hit by a bus. It means you get transferred to another department, anything like that. That knowledge might be lost, which means you've got to write it down. And the tip of the day videos in general are all about that. I would say that in a nutshell, the tip of the day videos are kind of about removing tribal knowledge. Tribal knowledge is when grandpa tells dad, dad tells you, and it gets passed down from generation to generation. But people outside of your tribe have no idea what you're talking about. They don't have that same information because they're not in the same tribe. It wasn't passed down. The tip of the day videos are about taking information that we think is useful and writing it down, or in this case, putting it on YouTube, so the information is there for a long time. And my favorite thing that I saw last week over the internet was something called the bus factor. I'd never heard this term before, and I thought it was wonderful. I really, really liked it. You can Google bus factor and read Wikipedia. But essentially, the bus factor is how many people would have to get hit by a bus for an entire project just to stop dead in its track, right? So if there's just one person that gets hit by a bus and your entire company stops running, that's a bad thing. If it would take 100 people getting hit by a bus to cause any real difficulties, that's a good thing. More information is available. Everyone knows how to do this job. And so we kind of run all of our tip of the day topics through that filter. It's like, look, if I was the only guy in the shop that knew this information and I got hit by a bus, how bad would that be for the shop? Probably pretty bad. And so we're trying to convey all that information. And the entire Haas certification program is kind of aimed directly at that. We're just giving away for free. We're passing along all the information that is essential to being a machinist in the Haas certification programs, making it easier for you. We're increasing that bus factor. We're making sure that if you don't have a mentor at your shop or no one's explaining things to you, we want you to be fully prepared your first day on the job and your first year and your first decade on the job. And we want to keep continuing to share everything we learn. That's our recipe for tip of the day. Learn something, turn around and teach it. And hopefully that's working out. And we learned a lot from you last week. You had a question about how to touch off tools, and we were going to make a video on how to touch off tools manually with a gauge block and this type of thing. And so we got all of your input from that, and we saw the dozens of different ways that you're doing it, and we'll make a video on it. We're going to write it down to reduce or increase the bus factor here, to make sure that everyone knows how to do this and that the information isn't lost. We're going to record it in the video.
And in the comments section underneath the video, everybody keeps tacking on more information for the snowball effect, and then we end up learning from you guys too that way.
Oh yeah. Oh
yeah,
yeah, the comments.
absolutely. In terms of setting your tool offsets manually, we were in talking about it more. It would be great if we could. I think what you'd really like is to have one best way to do it. But probably where we're going to be at is, this is usually the best way and the way that I like to do it. And here are some other ways that are sensible ways to do it without blowing anything up or getting really bad results. Alrighty, so stream's going great. We've got people here from Canada, India, Russia, Rwanda, Mexico, Indonesia, Argentina, France, Poland, Brazil, Spain, Syria, and Romania. Thank you, everyone. Now, I see a comment. I'm going to murder this name. Forgive me. Levant Ozigdici. He has a comment here, and he also had a comment that we were going to possibly tackle. In fact, I'll tackle his comment first from, I think it was last week. Any upcoming changes on VS Series chip conveyors, like real conveyors, which ST Series has? And the answer to that is, we already have that on some machines. Like a VF2, you can get a regular auger just in front, and you can also get a triple auger system. That's a couple of augers that run longitudinally along in the pan and feed chips into the front auger. Then if you move it to a VF4 or a VF6 size machine, you end up getting one with 4 augers and a true conveyor out front, just like the lathes have. And those definitely move. They are significantly more expensive, but if you're doing work where you're creating just mountains of chips, it's definitely something you should consider. So that's the first question. Secondly, Levant asks, recently when I tried to use G68, I got an error on wrong IJK values. If I delete G68, I don't get any error. I wonder why.
No idea. So we get these type of questions. So I'm a Haas applications engineer, and like most Haas applications engineer, I was a machinist before I came to work for Haas. So for years we did that, and I just say that to say that your Haas factory outlet has someone just like me. They've got somebody who was a machinist that was hired by Haas to help answer those questions on install and follow up. So typically the way these things work is that you call up your Haas factory outlet, you talk to their applications person, and they walk you through whatever is wrong with your specific program. If there's a weird problem where you can't get through or something, it might come to us at the factory. And to a lesser extent, you can email us something like that at tod@haascnc.com. But this is going to come down to looking at the program. Typically, when you get an error with a G68 code with an IJK, just realize that you're probably not rotating an I, J, and K all at the same time. That there's probably something goofy with the I, J, and K value that you're using for the rotation. And we really can't tell what the problem is until we look at that program. Where I would start is going to the Haas YouTube channel and go to Haas YouTube, type in G68, and we've made several videos on how to use G68. Go through those programs, those examples that we show you in the video. Try running one of those programs as an example. We've got bonus content, we've got examples in those videos. Try running those example programs and the example programs in the manual, the G68's in the manual. Run that in control, and then you'll see, okay, hey, that runs just fine. Let me try copying that format, that syntax exactly, and see if my alarm goes away. Otherwise, if you get stuck, call your HFO, call that Haas applications engineer, or send us an email at the factory, and we'll make sure we get you taken care of.
All right, here's a nice, probably open-ended one from you. Dennis Griffin asked, this is from one of the previous video comments. Got any near-miss accident crash stories? I like to learn from others' mistakes.
That's a good question.
I've never crashed a machine. Oh man, if I crashed machines. So for whatever reason, I had problems with when I was my first year on lathes. I stuffed boring bars. I got really good. I don't crash lathes ever anymore. I'm so cautious with those ID boring bars. So you retract a boring bar, the wrong way outside of a board, and you rip the part out. And bad things happen. So I've bumped a couple lathes during my first couple years, for sure. The first golf putter I ever machined out, I machined this thing out and the whole billet thing. I machined it all and it was perfect and beautiful in one part. And of course I made one part. And very last operation, I'm engraving the sole, I'm engraving the hosel, I'm engraving the pocket, and then I'm engraving a toe. It was a funny putter and had something on the thing. Very last operation on the very last engraving of this thing. I was in such a hurry, I was so excited, I literally messed up my touch off. And I drove my engraving cutter into this pocket. And so for years I had this putter with a 1/4 inch carbide single lip cutter sticking out of it on my desk as an example. And so we've all had those stories. Now, near crashes, those don't count. There's no such thing as a near crash. That's a miss. That doesn't count. Every program I've handwritten would have crashed had I not fixed it, right? That's why you walk through the program and you walk through your CAM system. So near crashes don't count. Those happen on a daily basis. Problems with the code that you fix, or you have to walk through a clearance plane on your CAM system. So I wouldn't worry about those. You just have to always expect an issue and just verify all of your programs. I remember spending a month on an engine block once and putting a big hole in the side of it where my CAM system spit out an odd rapid plane because I didn't know how to set some setting properly. And so I've made big mistakes. But again, one of my favorite quotes is from Teddy Roosevelt. Far better is it to dare mighty things than to take rank with those poor timid spirits who know neither victory nor defeat. Again, far better is it to dare mighty things than to take rank with those poor timid spirits who know neither victory nor defeat. I have made huge mistakes, and I've also grown exponentially because of those, because I've been on the front lines. You can't learn if you're not sticking your neck out. So if something bad happens, you just gotta pick yourself up and keep moving. And you paid for that experience, and it's you just grow through it.
Great answer. Great answer. Here in the chat, Cobras2 asks, okay, here's another complex one. Hopefully you can even get the gist of this, just me reading it. Is it possible to use G255 cancel dynamic work offset on a 3+2 Haas with 2 chucks and 2 work offsets? When I use second work offset, it goes back to the first offset for some reason.
On today's episode of Stump Mark.
So if they're running like they've got like an HA5C-2 or something, they've got 2 chucks on the same rotary.
I don't know.
I'm not sure. We'll look at that again, but absolutely, we switch between work offsets constantly. We'll G255 turn off dynamic work offsets, call up another G54, G55, G56, normal work offsets, and then we'll call up our G254 again. Now, if you've got a Haas rotary that's got twin rotary tables on it right now, there is an enhancement request into the software department to add another dynamic work offset position. So right now on your Haas machine, you can only set a dynamic work offset on one rotary at a time, one 5-axis rotary. If you've got a trunnion that's got 2 rotaries on it, you can only use dynamic work offsets on one of those at a time without changing your value from one to the other. You would have to change your MRZP from this one to this one. And we're looking at that, and I know that there's a software enhancement request to add capabilities to run a center of rotation for twin chucks for dual 5-axis rotaries. So I hope that answers your question. A regular single 5-axis with a single platter, single tilt, single rotary, no problem. If you've got a Haas rotary that's got a single tilt and dual rotary platters, no. You have to choose one of them to set your MRZP off of. And that's just the way it is today, but we're looking at adding a second MRZP for that second rotary platter.
Great answer. Thanks to everybody who is giving us a thumbs up. We really appreciate it. Almost 30 of those. That's awesome for a live stream. All
right, so here we have this is a quick answer. Extra Dimension asks, when do we get to see the Haas UMC 1500 Duo? Oh. And the answer to that question is probably very soon. We were just talking this week about taking a trip down to the production floor where we were building one currently and taking a walk around it. So we're probably going to be doing that in the very near future here.
I want that machine. that machine looks awesome.
Yeah.
There's been talks. It depends on what part you're making. Because like anything, should you buy a pallet puller? You should buy 10 verticals. You should buy a lathe and a mill and stick it next to each other, or buy a lathe with live tooling, right? And be done in one. It all depends on your parts. But just from the machinist standpoint, what a versatile machine. I would love to be able to have that table and then have the full giant regular rotary, UMC rotary right next to it. That would be a really, really fun machine for a lot of different parts, or for the prototype work that I'm used to.
Alrighty, this is a question from last week's stream actually. Nerdly asked, numbering all the tools in your shop and using non-matching tool numbers and offsets, such as T7 with G43H19. I guess I'm not sure how to use higher tool numbers past T31 safely. Is there something that's easy to say about that, or is it getting really complex?
So there's two different things going on here. I had an email yesterday from a customer that had a VF2 with an umbrella style tool changer. So he's got an umbrella style tool changer, and he had 10 pockets, just tool 1 through tool 10. And he was asking me, how do I use a different offset beyond that? Now on an umbrella style tool changer, your pocket numbers, pocket 1, 2, 3, match your T number. I call it T1, that always refers to pocket 1. On a machine like this, it's got a side mount tool changer, pockets are irrelevant. I might have a 30 pocket or a 50 pocket tool changer, but what tool is in that pocket at any one time really doesn't matter. The pocket tool table keeps track of all that stuff in the background. So if you've only got 50 pockets, but we have 200 work offsets, or 200 tool offsets, how do you take care of that? On the umbrella style machine, for me personally, I might leave pocket 10 or tool 10 open. And if I would run tool 1 through 9, those are always in the machine, tool 1 through 9. Now tools 10 through 199, right? Those 200 tool offsets, all of those tools, those don't fit in your 10 tool umbrella. What I would do is I would swap them out one at a time. I would say, okay, I would take out tool 10 and I would put in, tool 100, but in the umbrella style, pocket 10 always equals tool 10, so I would call it T10 H100, which means it's using pocket 10, but it's using tool offset 100. That's how you do it on an umbrella. On a side mount tool changer machine, it's a bit easier. You just go to the pocket tool table and you find out whatever tool you pull up. I'm not using tool 17 anymore, and I'm gonna put in tool 117. So now I've got, whatever. So you might only have 50 spots available, but you can drop any tool number into that spot on the pocket tool table. You don't have to have a mismatched tool number with your H value. And if you do that, if you're running T10 H100, you have to turn off setting 15 H&T agreement so the machine doesn't alarm out. We've got that in there as a safety to make sure that you didn't do a mistake. So you have to turn setting 15 off if you're mixing and matching tool numbers and H values. The H value means just one thing. It is the line that your tool offset is on. So this is tool offset 1, 2, 3, 4, 5, and this corresponds to a 5. That whole line going across, that really corresponds to the H value in your program. Line 5 is H5. Yeah, that's it. So lots of different ways to skin a cat. If you have more questions about that, you can email us.
Okay, so I can't remember if this is a question that came in via email or over one of the videos. Dustin Holloman asked, what pull stud grease do you recommend? And you brought in some props, I think, to answer that question.
Yeah, so we get this question pretty often. And I guess the number one question the viewers might be thinking right now is like, you're supposed to grease your pull studs? It's like, I've had this machine for 10 years. I've never greased a pull stud. Okay, this is back to have you ever crashed a machine? Question. I ran a machine once for 3 years, and for the first year, this machine had an HSK spindle. HSK, it's a different style spindle. It's not like Cat 40, SK40. And so for the first year I ran this machine, I didn't realize you had to grease the little fingers inside that keep the HSK tool clamped. And so in the same way, greasing a pull stud, so if I've got a regular tool, right, you've got these little pull studs, and there's balls in the drawbar that fit on there, and you're supposed to grease these little pull studs. Just a little bit right on the back side, just a little dab, just right there. You're right on the inside of this guy. You should grease those every so often, especially if you've got a machine that's got through spindle coolant. If you do a tool change, it might purge that coolant, and it might blow off all the grease at the end of the drawbar that's greasing those balls that hold onto the pull stud. And so you need to re-grease them by putting grease right on the back of your pull stud. The grease that we're going to use at the shop, it doesn't matter. You can go to AutoZone and buy whatever grease you want, but we recommend something that's got, we use this. We use a mobile grease. That's the mobile grease XHP 222. But what's important about this grease is this, right? It's a lithium compound grease. It's this guy right here, NLGI2. And what that NLGI2 means is that it's got excellent water washout properties. So this grease is tacky and it doesn't get washed out very well. I'm not going to touch it. I don't like all gross. So the idea is that it doesn't wash off easy. It sticks to stuff, which is exactly what you want for your pull stud. So the coolant doesn't wash it off and you end up with a dry, spindle, package there. And so find yourself some NLGI2 grease and just put a little dab on the pull stud. Don't use a lot. You don't use a lot. I see people like putting big globs. I hate that. And then a big glob on here, and then it goes, spits out the coolant, and then it gets on the tool shank, and then you go to, you wipe off the tools, and your hand's all gross, and you get your spindle all gross, and chips stick to it. That's way too much grease. Just a little tiny, pea-sized dab, and then wipe it all the way around the pull stud, and you're fine. And if all your tools have it, you don't have to do that but once in a blue moon. But certainly, every couple months, every few months, you should just go ahead and take a look and make sure there's at least a film on those pull studs. And talking about that HSK, this is different. Pull stud grease is different than the fingers inside of an HSK spindle. But if you've bought a new Haas recently and it's got an HSK spindle, we've given you some instructions on how to grease the little fingers. You can put a spray in there, a little brush, and you can go in. And it's important that you do that like every month or more. Because if those fingers aren't greased, they'll dry out, and kind of like greasing a chuck on a lathe, you'll start losing clamping pressure on your HSK tool if you're not greasing it. And so this isn't our tool. We don't make this guy, but I'll mention it because I think it's awesome. This guy is a Rome Luger tool, and it's an HSK package. And this right here is actually a giant grease cartridge. So this is just this thing's expensive. It ain't cheap, but it's so stinking easy. What happens is you just put it into your tool changer, and every time this tool is called up into the spindle, it greases all the little fingers inside of your HSK spindle. So it automates the greasing of that chuck, so you don't have to stop and do it manually. The first time you grease an HSK spindle, you're going to spend 40 minutes doing it, just figuring out where you got to put the grease inside the spindle. You'll get faster. Eventually, it's going to take like 5 minutes. So 5 minutes once a month is not a big deal. But if you've got an HSK spindle, remember, you got to grease that thing. It's important. And so learn how to do it manually. And if you've got a bunch of Haas machines with HSK and you need to grease them faster, this is kind of an easier way to do that. You just put it in the spindle, pull it out of the spindle, or leave it in the side mount tool changer and call it up once a month, and it greases it for you. So that's just another an option for greasing your tools.
Cool. Chris Fletcher here in the chat asks, is there a way to disable tool offset measure? We've had multiple operators push that, thinking they were pushing the chip conveyor button, and then crash the machine. Is that something we can disable?
So there's under settings, there's a panel lockout here. So I'm going to type in, this is an NJC machine, same setting on Coldfire. Coldfire is the classic control. Thank you. So if I come in here and I type in lock, down arrow, F1, there's going to come to setting 6, front panel lock. So I'm going to turn front panel lock on. Don't do this unless you know what you're doing. But if I come in here and I lower it down, I go to my offset page, and I press tool offset measure, it's still doing it. So let me see. So I can't lock it out that way. I'm thinking real hard here. I'm not sure there's an easy way to do it because it's critical to doing that. We have keys on the side. Oh, my keys are gone. My next thought would be if the panel locks don't do it, if the let's see, other locks, spindle locks, tool release lock, M39, offset lock. What? So we also have an offset lock setting 119 that you can go in, and after the setup person has done the setup, you can go to setting 119, offset lock, turn that to on. Now on the offset page, if you actually press tool offset measure, offset table locked from editing. So it will not allow me to change an offset if setting 119 offset lock is turned on. So that's one way to do it. There's also keys on the side. Depending on what software version you have, those will lock things out and keep you from changing those. Beyond those few locks there, so again, go to the settings, check out your setting 119 offset lock, or check the keys on your machine, try setting an offset with a key in one position, setup mode or run mode, and you'll get different responses based on your software version. But those are kind of the two ways that I would look at that first to try and lock out those offsets.
All right.
Hey, 205 simultaneous.
Yeah, here we are getting to the end of it, and we're growing the number of people on the chat.
54 thumbs up. Thank you.
Odalus Ferreris has just been blowing us up here. He's asking about I'm assuming arc filter tolerance, master. I think he has a question about setting up arc filter and tolerance on Mastercam with Haas CNC mill.
Sure.
That's going to be a tip of the day kind of thing, right? Or,
yeah, so in the cam system, every cam system has that arc filter, and unfortunately, it almost varies based on cam systems. On some cam systems, you set it to 0.2 of a thousandth of an inch, and it's all you need. And other ones, you set it to 50 millionths or 5 millionths. There's all these different numbers that you would use. The closest thing we have to that is we've got it's not Mastercam, we have an Autodesk video on G187 that touches on that. Talks about those filter tolerances. And I have a video called G187. Both of those are G187 videos. So go to the Haas YouTube channel, look at both of the G187 videos. They will at least make you aware of what those fit tolerances do, because you'll watch those videos and you'll see a 3D surface that looks great, and you'll see a 3D surface that looks terrible, and part of that can be fixed but through the use of a G187 command, a G187P3, but a lot of times the code put out by your CAM software, it needs to have a better fit tolerance. So it really depends on the CAM system there. So talk to your CAM system supplier, talk to them about that fit tolerance. But again, typically two things happen. You set the fit tolerance too big, and your part is all faceted, especially on 3D parts. It looks all blocky because you're using too large of a fit tolerance. On the flip side of that, if you set that number to too small, 0.00000000001, then you're going to end up with a billion lines of code, and the machine is going to choke on that code. We can run a certain number of lines per second, blocks per second, and if you set that filter too high, it's going to slow down your program. So there's got to be a happy medium for those fit tolerances, and it really depends on the machine that you're running and the CAM system that you're using as to what those numbers really need to be. So you'll have to do some playing around.
All right, we're just about to wrap this up, but let's do one more from one of the questions from earlier. Richard Palomers, which looks like is maybe the real name of the alias, the Instagram alias Dat6Z06. Z06, it's hard to say. Dat6Z06. Can we change out the ruby tips on the probe to a smaller diameter?
Oh yeah. Yeah, so they come in lots of different sizes, lots of different lengths, lots of different diameters, where you might have, like a 5 millimeter, 3 millimeter. You can get smaller Ruby tips, and all you have to do is just requalify the probe. So just go through and recalibrate your probe, and you can just buy those right from Renishaw. And so yeah, they make them in a gazillion different sizes, just for anything you need. And they make star probes, so you can come in and probe sideways and lots of weird things. But absolutely, those probe tips come in different sizes, and they're really easy to set up. All you got to do is just run the calibration process again.
I've seen a couple folks in the chat asking for your email address, Mark. Where can people send their questions to via email?
Frank Zaragoza at gmail.com. No, that's not your email, is it?
No.
Okay, good. So, man, some Frank is gonna get a lot of emails. TOD, which is tip of the day without the. I don't know why I asked for this email address. TOD at haascnc.com. So if you have something you'd like us to talk about live on one of these broadcasts, or something that you think we should make a video on, or you just need some help with something, if I can't answer the question, what I'll do is I'll hand you off to one of our many applications or service guys who know everything about the machines, and we'll get you taken care of.
Thanks for that, Mark. And
yeah, I think that's a great way to wrap it up. I mean, here we're going to be at nearly an hour again. Thank you, everyone, for joining us, especially after the stream dropped off there for a minute. Thank you, Mark. Thanks, Frank.
You're welcome. We'll see you guys next week.
Fantastic. Catch you guys later.
Thanks for tuning in. See you next week, guys.
Thanks, Eric.